Hi, hello.
Hello.
Hi.
Let's wait a couple more minutes to see if more people will join in. So we have already a couple of people here, so maybe we can start. This meeting is recorded, so maybe other people can benefit from it as well. Let me start with quickly introducing myself. My name is Niels. My background is computer science, diploma and PhD. I then started to work at TNG, where I'm now for a little bit over 9 years. So I was active in a couple of previous projects, mostly development, but also sometimes in more management positions. Here at Magma, I'm mostly active in, was mostly active in the basicification effort and also in CI topics. And CI topics is what I want to talk about today. As you know, there is some changes in the community structure ongoing, and it looks like, a couple of us will change projects in the next couple of weeks. We did a lot of work in CI, and of course, we want to do a handover for these topics. With me here are today Lars and Marco, colleagues of me. You see it on the background. They will support me with also answering your questions and giving more comments in detail what I'm trying to talk about. So let me share my screen. Whoop, 1 second. So I prepared a page here. The page is very empty. The main part here will be the recording, and Marco will also add some documentation if there are additional questions, so we can document for follow-up meetings. And let me say, we are open for follow-up meetings. So the first session today will be very general, and we can do deep dives into other topics as well, but let's make this depending on the feedback from today. So, as I said, I want to start very low level. Please let me know if it's too low level and you know about this, then we can increase the pace a bit. But what I did was I created a dummy pull request. That is not a pull request to be merged. It's just to give an overview what is happening if someone starts to contribute in this direction. And I want to then go over what CI in Magma is triggered and what we can see there. So first thing we see here that the pull request has a couple of reviewers assigned. These reviewers depend on the reviewer groups, and the reviewer groups are depending on the configuration of the Magma repository. What we have in the repository is a file called code owners. This file defines who will be assigned to a review. So this is really straightforward. So what we see here is a relative path in the repository. And we see, for example, here for LTE gateway Python intake tests, if there is a change in a pull request in this folder, then the reviewer group Magma approvers infra will be assigned. Same holds for other examples. If something in the NMS folder is changed, then the approvers cloud group will be assigned. And the last reviewer group we have is the gateway group. So if, for example, something in orchestrator gateway C is changed, then the approvers gateway group will be assigned. There is one additional group, the approvers TSC group. This group owns this special file here, so this needs TSC approval if this is changed, and also if the documentation about the how a proposal is managed is changed. The ghost group is special. This group does not exist. This handles auto-generated files that should not be reviewed. So in some cases, there will no additional group be assigned. So if I create the pull request, it is determined what reviewer groups are important, and by random, people from these reviewer groups will be assigned as reviewers. This means in this case, one of these two people here must be in two groups, actually. So it's sufficient to only assign one person here for these two groups. And one important point here is if you see a pull request and you get an email that because you are in one of these groups, but you are not actually listed here, please feel free to do the review anyway. We currently have a lot of inactive people in our code owner groups. There is an effort to clean this up, but this is ongoing. So again, please feel free to do a review anyway. Even if you are not in this review group, you can also do a review. You can give feedback. It's always helpful. No? Let's go over to the CI parts. If we scroll down, we see here the list of checks that are running. Now, for Magma, this is a very long list. And let me say, my personal opinion, GitHub did not yet find a good way to present these checks in a good visual way. Yeah? So actually, this list is very small. You have to scroll in it. You see some summary, how much checks are failing in this case, and so on. Yeah? But there's no filtering or stuff like that. So this is a little bit cumbersome, but again, personal opinion. What you can see here is that a couple of these checks are required. Yeah? This means if these checks are not green, then this pull request cannot be merged, even if all reviewer groups give their okay for that. Yeah? So in this case, if I scroll down, I see here that 5 checks have been failing. We see, for example, that here a Python format check failed. It is required, and this cannot be merged. So this needs to be handled first. What else do we see here? We see this little icon here at the beginning, this GitHub logo icon. This usually means that this is a workflow, a CI check that is configured inside of Magma. So if we see this here, then we know, if we look in the code, we have a folder .github here. There's a workflows folder. There are a couple of YAML definitions files. These are our workflow files. So these are workflows defined in the Magma repository. So we can actually have a quick look what is happening here in detail. But we also see other icons, but not much. For example, here, this is a little penguin, I guess, and this is for the Magma OAI Jenkins. So this is not a workflow defined in Magma, but this is a workflow that runs on the Jenkins that is managed by OAI. It's externally. We have some possibilities to see the logging if something fails. But for example, for this job, it's just more feasible to contact OAI to ask them to help to debug what went wrong there. There are a couple of others. This little umbrella here, this code cuff, this is an external tooling for managing code coverage. So we can see if the code coverage changed for various modules of the project. And last but not least, we have this little beer, the merge freeze. This is not active. I don't know actually if it was used before, but it is, of course, used for releases. If we have a state where we want to create a release and we don't want to allow merges to the master until the release branch is pulled, then this tooling can be used in order to prevent merges to master for a period of time. So let's take a look in a failed run. Which is most interesting. Here, HEW build, format, and test Bazel. So the workflows itself have a kind of semantic naming scheme. So first is the component, and then what is happening with the component. So the access gateway is built in this workflow. Some formatting checks are applied and tests are executed, and everything here is happening with Bazel. So I, on purpose, made this workflow red because it's one of the more complicated workflows. And I just want to use it as an example. But if we click on details, we get directly to the login to the failing step. A little bit for the naming. What we see here is a workflow run. A workflow usually consists of various jobs. Jobs can run in parallel or sequential. This depends on the definition. And each job consists of a couple of steps, and the steps then run sequentially. And we see in the workflow, AGW build, format, and test with Bazel. The job Bazel test job failed in the step run Bazel build and test. And actually only one test was executed because to do a little bit advertisement, because I worked a lot, especially with Lars on the Bazel topic. Bazel is very efficient here because Bazel checks what code was touched in the pull request, and only tests are executed that are relevant for that. So only one test is executed here because I actually did a change in the test. And if we scroll up, we see a stack trace, we see an assertion error that true is not false. So I just changed an assert to show what is happening here. So as I said, the workflow consists of jobs that run in parallel or sequentially. We can see a visual presentation if we click on summary. And this is what I meant. This workflow is a little bit more complicated. So we have a lot of jobs that are connected by a dependency structure. So path filter, we have this in a lot of jobs in our CI. It actually does a pre-check what files were touched and if this workflow should be executed at all. The Bazel diff job is what I was talking about, that we calculate what paths build targets were actually touched in this pull request and needs to be executed in order to be efficient. And then here is a matrix job where we execute unit tests for different configurations. So we have a production configuration, we have a configuration with leak sanitizer, and we have just execute all unit tests without depending on leak sanitizer or address sanitizer. Yeah? And here, this one job was failing. The others are not failing because the leak sanitizer and address sanitizer runs are only interesting for C code, for C binaries. And I did a change in the Python library. So CI works good. Or one thing that is sometimes not good in CI is if CI is flaky. This can happen for various reasons. Some of them can be managed, some are not that easy to manage. And to be honest, we still have a lot of flaky runs in the Magma CI. So in a lot of cases, it makes sense to first restart a job, see if it's green in the second run, and afterwards, if it fails a second or third time, to take a deep dive and see if the real reason can be found out. It's easy to restart the job. Just here in the upper right, rerun jobs. We can do rerun all jobs, then everything is restarted. We can do rerun failed jobs, then just the failed job is restarted. I would say go for all, always start to rerun all jobs, because in some cases it's not possible to rerun only the failed jobs. Actually, in this case, it would be possible, but we have a couple of workflows where, for example, a job publishes to the workflow some artifacts, for example, Docker images. The next job downloads these images and for efficiency then deletes these artifacts from the previous job, and then it's just not possible to rerun only the failed job. So to have it easy, rerun all jobs is what I would go for. Yeah, let me take a quick break at this point. I already talked a lot. Are there any questions? And maybe I forgot to say this at the beginning. Please just stop me if there are any questions. Or maybe Lars and Marco, if you have additional comments. Okay.
Maybe just one comment to vindicate the Bazel workflow. So the Bazel workflow is not one of the flaky workflows, just to be clear. There are a number of workflows, and we sort of know the reasons. I don't know if we're going to go into detail on those today, but yeah.
Yeah, I will talk about a couple of the flaky jobs. Yeah, but right. Usually this Bazel workflow is very stable, and if there is a failing or a red job, it's usually worth a look to check if some unit test broke. So yeah, as I said, there's required and non-required jobs, but I mean, kind of obvious, but I would recommend to also take a look into the non-required jobs if they are failing. They are not, in those terms, important for a stable Magma. These are usually jobs that, for example, do linting. So if a linter fails, then created artifact is not broken, but of course it would be good to take a look. And in some cases, it, in my opinion, should also be discussed if this might be more important as a required job. Yeah? Okay, these are the checks that run on if a pull request is created or if a pull request is updated. But we actually have more workflows. So we have also workflows that do not run on pull requests. The reasons there are various reasons to do not run a workflow on a pull request. The main reason is there are workflows that take a couple of hours. For example, integration tests. We have long-running integration tests, and nobody wants to wait a couple of hours for feedback from the CI if a pull request is created. Another reason is that some workflows create artifacts. So for a pull request, we don't want to create artifacts that are published to some artifactory, for example. We only want to do this if something is reviewed and merged back to master. It is actually not possible to run those workflows on a pull request, because for publishing, we of course need some credentials, and GitHub restricts this. So if you create a pull request, it is usually created on a fork, and then you cannot use the secrets that are configured in the Magma repository. It runs in the Magma infrastructure, but it's not possible to use the secrets for security reasons. No, apart from that, it does not make sense to publish these artifacts. You can get an overview of all the workflows by clicking here in the top on actions.
Actually, Nils, can I ask a question about that?
Yes.
How do you develop and debug workflows that require access to those secrets?
In both cases, you can create a branch in the Magma repository. So then I would not create a branch in my fork, but on the Magma repository. This is only possible if you are a maintainer. So there are restrictions, but then it's possible to also use the secrets. In some cases, it's a little bit more complicated. For example, if you create a completely new workflow, then GitHub has some restrictions that the workflow only appears in the overview, and I will talk about in a minute, if this workflow was merged on master first. So this might be a situation where you need several pull requests in order to kind of register the job and afterwards then test it on a branch.
Maybe to add to that, so just if you're developing a completely new workflow with new secrets, then it's probably best to first test it in your fork with the secrets configured on your fork. The fork can have completely separate set of secrets. And when you're sure that everything works in a test environment, then change the secrets so to merge it to Magma, then use a completely new set of secrets and so on, and just merge the workflow there.
Yeah. Okay.
And also, yeah, also like a short comment, in the most workflows, these secrets are limited to Slack credentials or credentials to the Artifactory, which you may just delete for testing purposes. These steps are not necessary usually to run the tests. So you may be able to adapt the workflow file on your fork by excluding the steps that require the secrets, because for testing purposes, usually in most cases or in a lot of cases, you don't really need the secrets.
So then this is the overview of all the workflows that are currently, let's call it, registered on master. So for Magma, these are a lot. I just want to we all already looked into the Bazel workflow. I want to have a look into another important workflow. And this is the Magma build and publish. This is also a very large workflow. that does a lot. And this workflow runs on master and on pull request. So you can see this here, that you see here a branch. I mean, each entry represents one run. If you see here a branch that is not master, then it's usually a pull request. If you see master, then this run originates from something that was merged to master. So what we see here is a big time difference. For example, let's take here. Here is one branch, removes Juju deployment, and afterwards is a run on master, where this was actually merged. And we see on the branch, it only runs like 20 minutes, and on master, it runs almost 2 hours. So let's take a quick look why this is the case. I open both runs. This one here is the one that runs on a pull request. And what we see here is this gray little symbol. This means skipped. So the AGW build is actually not executed on pull request runs. And we don't need to publish to Firebase. I will talk about this a little bit later. And we don't want to trigger the Debian integration test runs. But almost all other jobs that run. For example, we have an orchestrator build, carrier Wi-Fi build, FEG build, NMS build, and so on. So on a pull request, we check that these components can actually be built, that nothing is broken there. But if we run this on master, then we see here is the big time consumer, the AGW build. In the Bazel workflow, AGW artifact is built with Bazel. In this workflow, the same artifact is built with make. With make, this takes a long time. And again, advertisement because of my Bazel involvement. Bazel uses a lot of caching. The same part takes there between 7 and 15 minutes, depending on the changes, but it's a lot faster. Yeah. So, and on master, these artifacts are then also published. They are published to the Artifactory. We might come to this a little bit later, but then actually stuff is uploaded. Yeah.
Any special reason why we are using make in this case?
This is, I wouldn't call it historic reasons, but I mean, usually Magma was built with make. The Baselification is an effort that is still ongoing, and here it is not switched to Bazel. So, and actually it would not need to be switched to Bazel because we're doing this in another workflow. So the question is if this job here is still needed. But this is something where we want to open a discussion in follow-up meetings, not in this meeting. But the question is if the community wants to take over Bazel and drive it forward. The effort is very progressed. So, but there are still a couple of points open. But the question is if somebody wants to take ownership of this topic.
Niels, if I may.
Yeah.
What percentage of make do you think is still there? Is it 10%? Is it pretty much 70–80% has been converted to Bazel? Just the top of your head.
So, one important point is the Bazel effort only considers the AGW. Yeah. So not the orchestrator, not NMS, so not the cloud part, but only the access gateway. So, and Lars will correct me in a minute because he is currently putting a lot of effort into this topic. But currently we can do everything with with Bazel that we can do with make. So actually we have everything covered. But for the switchover, of course, it would be needed to remove the make parts, the remaining. And a couple of parts are still there. For example, we have a couple of integration tests run that's still using make created environment, and this needs to be switched. Maybe Lars, you want to take over if you see big open parts.
Yeah, no, that's accurate, I think. So it's mainly the FEG intake tests still build the access gateway with make currently. There's no reason why this is done, and it's currently in progress to switch that over. Everything else, yeah. So concerning the access gateway, we can do everything with Bazel. There are just some things that are still also done with make, like building the Debian package. We're already building it with Bazel and publishing it, but we're also still doing it with make. So depending on the community, these steps can be removed from the make side. So we already don't have the unit testing, for example, with make anymore. That's already just done with Bazel. But there are just some steps that we haven't deduplicated again. And so there's a lot of cleanup, and there's some cleanup efforts going on. Yeah. But so in terms of what we can do, it's basically 100% for access gateway.
So we now have taken a look into what is triggered for a pull request, what CI, and how to look inside. Maybe before we go to the rest of the post-merge workflows, we can take a quick look into a definition of such a workflow. So let's take this Magma build and publish. We can see here the name of the workflow definition, build-all.yaml. So let's open this one. So here it is. And as you can see, it's a very large workflow definition, roughly 750 lines. But just what one would do for debugging. So if I see a certain step in a job is failing, how can I find it? At the beginning, what I see are the triggers. So when is this workflow started? Workflow dispatch, not a nice name. It basically means this workflow can be started manually from the CI overview. This is workflow dispatch. It's also triggered if we have pushes on the branches master and everything starting with v1 dot. So if we have a merge to master or to one of the release branches, this workflow is triggered. And it is configured for pull requests. So if I create a pull request based on master or one of the release branches, and this pull request is opened, reopened, or synchronized. So if I do a change, then this workflow is triggered. Now, then we have a big section, jobs. So these are all the jobs, and it's basically the rest of the workflow file. One is build and publish Helm charts. And if we then take a look here to the overview, we can actually see it here, build and publish Helm charts. And if we click inside, we see the steps. And we have, let's see, we have here a step save PR number. And of course, we can see it here as well. So if this step would be failing, we can try to look here into the code and try to debug it, try to reproduce it locally in order to figure out what is happening there. Yeah. So this would be a very general way to find then more information. So what else are there for the workflows that are triggered after something is merged to master? In terms of releases, these are the important workflows because we want to release only a stable master. And for this, actually, we have an additional overview, Magma CI web app. Takes a little bit to load. As I said at the beginning, in my personal opinion, GitHub never managed to have a nice overview for workflow runs. I don't know if people are here who work with, for example, Jenkins before. Jenkins has a nice plugin called Build Monitor that is very helpful. I don't know why GitHub is not offering something like that. But this page has two purposes, in my opinion. One purpose is to have something like build monitor overview. The second purpose is we are actually also displaying workflows here that are not modeled by GitHub workflows. And I think the only example currently is WL5G. I think this is managed by Connect 5G. Jordan, correct me if I'm wrong, but this is a workflow.
No, this is Wavelabs. No, this is from Wavelabs.
Right?
We are not, our pipeline is not integrated, yes.
Oh, okay, sorry about that. So then this is managed by Wavelabs. It's 5G tests, and this is not running in the GitHub CI, so it's running externally, but nevertheless, the results are published here, so we have a nice overview. Yeah? So not all workflows are listed here that run after a merge, but let's say it's an important overview. So what do we see here? We see here a build ID, a run. So I think this actually corresponds to a revision. What branch is relevant here? Currently, you only see master. Sometimes you also see here release branches, but currently there are no backports ongoing. Who did it? So Marco did the last merge here. And what jobs are we seeing here? We have two sections. We have builds and we have workers. And builds is actually a summary of the build all workflow that I was showing you before. So the AGW build, this is the make Debian build. The ARM AGW, this is currently not enabled. I think it was never enabled. This was actually planned as a workflow running on AWS. Because GitHub does not support ARM architecture right now, or we are not using it. So this was never enabled. FEG build, so these are Docker builds. Same for Orchestrator, NMS, and the carrier Wi-Fi gateway. Then the external 5G tests. And here we go to tests. So these are builds. And on the right-hand side, we have tests. So the first important are the so-called pseudo Python tests. This name has historic reasons. The name is not good. I don't like it because it's not very descriptive what is happening here. But for now, we decided to not rename it because in documentation and in code, you can still find it. And people should think about if it should be renamed. So why pseudo Python? These are tests. The Python tests are executed with PyTest, and actually these tests needs pseudo privileges to be executed. But what is more important is not the pseudo part. These tests are something between unit tests and integration tests, something in between. So these are unit tests that need a little bit more. There are tests that need the Open vSwitch setup, and there are some tests that need a certain network setup. But at the end, they are not need as much as real integration tests, and but are a little bit more than unit tests. So for this part, I created, I wouldn't call it a slide, but a short summary, and I will open this again. But this is about the topology of the machines that are needed for testing. For the pseudo tests, this is really easy. The pseudo tests run in the so-called Magma VM. Now, this is one virtual machine. So, but the benefit here is this machine already runs the Open vSwitch setup and has needed network setup that are also needed for a couple of tests. And in this VM, the tests are just executed. That's it. So the topology here is that we only have one running virtual machine for executing these tests. It's more or less easy. Yeah? Let's take a quick look where this is defined. For this, we have a Vagrant file, and the one that is interesting is in LTE gateway. And here, various virtual machines are defined. And at the beginning here, the Magma VM is defined, and this one is used, for example, for the sudo Python tests. This virtual machines is based on a basement image that we actually from time to time update and upload to the Vagrant cloud. So in the last couple of months, Marco took care of that. So from time to time, he rebuilt the these base images with Packer, tested them, and then uploaded them. This is needed from time to time because some dependency changes and stuff like that. And if you don't do it regularly, then it will take a lot of time to actually create another VM that is based on this base image, because a lot needs to be updated. And various other steps are needed for the upgrade. Marco, maybe you want to jump in with a couple of sentences about that.
Yeah, sure. I mean, as Neil said, we have a lot of dependencies in these VMs, which do get updated. For example, we upgrade to a later Go version, and this version, for example, needs to be installed on the VM, which means we have to download the respective files and install them, which takes time, and depending on your bandwidth, of course, more or less time. So what we do, we do such installations only once in the space images, upload them. So for you, it's then you just download this image once and have quite a short time that it needs to fully provision them. And in this case, fully provision means you just link certain Magma config files to the directory you would need it in production, and that's it. So with this, we basically have, or we take less time and less of your internet bandwidth for provisioning these VMs on your local machine. And at the moment, we do this, let's say, every 4 months, probably. We did it in the last, well, almost year now, because we had quite a few changes done to these machines in order to keep up with external dependencies.
So there's also an effort from Marco. He created a draft pull request to more or less automate that. So a workflow that actually rebuilds these machines. But this, again, is something that needs a driver, an owner who wants to take over the topic, because this still needs some effort and testing in order to have this in CI to minimize the, or to automate the effort there a little bit more. Okay, so this was about the sudo Python tests. The next one, let's jump a little bit. Let's jump to this one. LTE Integ Debian. This is actually execute the integration tests versus an environment where Magma is installed as a Debian package, and the Debian package that is used here is currently the Bazel Debian package. This means you have seen the Bazel workflow before. I will quickly reopen it. It is still open. So if we are on master, then the Bazel package job runs. This creates the Debian artifact and uploads it into the Artifactory. Then the same job will trigger the integration test. So the integration test then downloads the just created artifact, the workflow, and executes the integration tests. Let's take a look there. So integration test, HEW test LTE integration with Bazel Debian. You see, our integration tests are currently flaky. I will come to later to that, but in general, it's possible that they are green. And why they are red a lot of times, this has two reasons. We have flaky tests, and we also have, in some cases, a flaky infrastructure. Yeah, again, I will go into detail a little bit later. So let's take a look at one run here. And here, the jobs, there's only one job that executes the integration tests. And we see a couple of steps. And the long running step here is run the integration test, where the tests are actually executed. Now, let's go one page back. And here you see something that you see on for a couple of workflows. Almost all workflows that execute tests will have at the end some summary here, where you can see how many tests were executed, were successful, and how many tests failed. So if we open one that failed, let's take this one, and we scroll down, then we actually see that exactly one test failed. The rest was successful. And now we can click on this check and get an overview what actually failed. And in this case, it was test attach detach set session rules TCP data. We can also have a look at the output, what failed there. So if we scroll down, we get a little bit more information. We get runtime error, cached result is not a tuple. So at some point, a tuple was expected, but none was passed. Should be analyzed, but this is already a good hint what failed here in order to do a deep dive in the analysis why this happened. But again, this seems to be flaky because in other runs this is green. So flaky tests are sometimes hard to debug, but at least this is a starting point. So what tests are actually executed here? The easiest part to find this out or to get an overview is in a file called devs.mk, located in LTE Gateway Python integ tests. And here is listed what integration tests are executed. And if something is merged to master, we have a long list of so-called pre-commit tests that are executed. So a very long list. We have so-called extended tests. Extended tests long, a small list, but as the title says, they have a long runtime. So each test runs about, I don't know, 10 to 15 minutes. It takes a little bit longer. And then we have here a final list called non-sanity tests. And this is something, again, this should be revised, but an owner is needed and a driver for this topic. These tests are not executed in CI, and they never were for the time when I was active in the project. So it should be revised and checked if it makes sense to execute them in CI, or to at least document in what cases it makes sense to execute them locally for debugging reasons. And there are a couple of tests that are currently commented out for various reasons, also for a long time. And also here, it makes sense to take a look at what is happening there. the list below, federated tests. This is a subset of the pre-commit and extended tests that are executed on the federated gateway integration tests. Again, let's have a quick look at the topology in my wannabe slides here. So first we have the pseudo tests, and now the HEW Debian integration tests. So this time we don't use the Magma VM, but we use the so-called Magma Deb VM. This is the base image here is not a pre-built image, it's just a focal image. So the idea is here we want to execute the integration test on versus an environment that is as near as possible to a production environment. Obviously, we need a couple of changes because the integration tests need a little bit more access than a production environment allows, but it's more near than using the Magma VM. On the Magma Deb VM, we just run the access gateway installed by a Debian package. And in this case, the topology is a little bit more complicated because we need two additional virtual machines. One is the so-called traffic server. The traffic server provides by iPerf uplink and downlink traffic, and also kind of new a DHCP server for tests that need this feature. And FYI, for the Magma traffic server, this is only needed for some tests. Not all tests need a traffic server, only the uplink downlink tests and the DHCP tests. But apart from that, for a lot other tests, the traffic server is actually not needed. And last one, maybe most important, the so-called Magma test VM. Here, the tests are executed. So the tests are written in Python. I have shown you the files and the categories that we have here. These are the tests written in Python. Additionally, on the Magma test VM, we have the so-called S1 AP tester deployed. This is also located in the Magma account, but it's a separated repository. So this is a C-written tool in order to simulate communication for the integration tests. I think there are a lot more people in this hall who have more knowledge about that. But I think it's sufficient to know that this tool is used in order to execute the integration tests. And we already talked about the devs MK, where the set of tests that are executed are defined. So then let's jump back to the overview. So we talked about the pseudo Python test and the LTE integ Debian test. Another interesting part are the LTE integ containerized tests. As release artifacts, we have Debian artifacts, and we also have container, so Docker artifacts that we publish. Yeah? And this is maybe the newest integration test that is included here. And you can see it's very, very flaky. So let's have a look at this one. This is located here, HEW build, publish, and test container. I see it loading. I don't know why it takes so much time. So, as you can see here, it's also one of those jobs that are executed on pull request and when merged to master. When it's merged to master, let's scroll down. A master run takes almost 5 hours. On a pull request, it's a little less than 1 hour. On a pull request, only the images are built. On a master merge, also the tests are executed. So I will just open one here. So what we see here, this workflow is a little bit different structured. So what we see here is that the tests are actually executed in parallel. So the pre-commit test, the extended test, and the extended test long. And in this case, we can see the extended and extended long tests were successful. For the pre-commit tests, if we scroll down, there seems to be a larger issue because there were no real test results created. This can happen, for example, if the VM had an issue coming loading correctly, then nothing happened at all. But here we don't have a good result. So why are these tests so much more flaky than the other integration tests? Let's filter this down to master runs where the integration tests are executed. Yeah. No. So we see a couple of green runs in between. Yeah. So the jobs have the potential to be green, and the red runs are expected to be flaky runs. As I said, these tests are very new. It took a lot of effort to prepare the environment to make it even possible to execute the integration tests. At the first effort or the first throw just executed a subset of integration tests, and then step by step we added more integration tests and fixed them or make them runnable. And at the last step we added the rest of the integration tests. So it was actually our goal to see how flaky it is. It is flaky, and it needs to be analyzed in detail why several jobs are not running in a good way on this environment or versus this environment. One current hypothesis is that a couple of services take longer to restart, for example, the containerized MME, and this can make a couple of tests fail. Marco, for example, took some effort to create statistics about that, but this is ongoing to analyze this in detail. Again, let's have a quick look at the topology for this one. So this is the same topology as for the carrier Wi-Fi, FEG, AGW with Make, and the container tests. So what we have this time is roughly the same topology as before, but this time we are using the Magma VM and not the Magma Deb VM because we need a couple more tooling installed. It makes sense, for example, for the containerized test to maybe put the effort in to use a focal base image here as well. But for now, it's the Magma VM. So again, we are running the access gateway. In this example, containerized. The traffic server and Magma test have the same workload here as before. So again, there's not much difference in that. So we have 2 minutes left. I have a couple more points, but we can move it. So I would like to use the last 2 minutes to ask for feedback. Does this format work for you? Are you interested in more of these meetings? We are happy to prepare them, but the question is if it was helpful for you.
I mean, for me, it's perfect. And definitely we need more format, more of this format. We need to see how some of the, I mean, what are how we troubleshoot some of these workflows in more details. And then we need to see also how we build these virtual machines, because everything depends on them. I mean, for the virtual machines, we will need to most probably get rid of them at the end, because they're preventing the proper integration for ARM. As you know, for ARM, yeah, to build the ARM releases, we are actually removing everything from the VMs. And we are building them either in Docker environments or we are building them on physical environments. Otherwise, it won't work. We cannot build it with the Vagrant. But while we arrive there, it will be most probably 1 year until we come to that point. So we need to maintain them, and we need to see how they are built and the whole process. And maybe even that one will help us to either create the similar thing for ARM and then use the virtual machines on x86 or ARM, or find a way how to get rid of them. So, I mean, enough from me if somebody else wants to comment.
I also found this helpful and productive. I didn't know a lot of the stuff that was just discussed in detail, like the role of the VMs. And there's a lot going on in there. So.
Okay.
This is a deep subject, but I think we need a couple of more of this session, definitely. May I recommend that we do another one in about 2 weeks' time? And also like to invite some other people a little bit more, make it a little bit more visible so people can start participating and so on. So
Yeah,
that's my
we can start promoting it on the announcement channel to everybody. I mean, this time we didn't promote it properly, but we can start even, tomorrow start promoting that. In 2 weeks we will have it, or in 1 week we will have the session. Depends from Niels.
Yeah, I mean, I promoted it in the dev and general channel, but I would be happy if there's more advertisement. So it would be nice to have more people here. So a couple of topics I had in mind. I mean, feedback now was that also it would be interesting to have a deep dive into creating these virtual machine base images and maybe the actual provisioning. So this would, for example, be a topic for Marco that he would be able to host. Another topic that I find really important is the release. So to go through steps needed there, especially in terms of changes, because we are using a new Artifactory and a couple of manual steps are now not possible anymore and might be more difficult for the next release. Yeah. Okay, we are already over time. So thanks a lot for your listening, for your participation, and for your feedback. We will think about a next appointment and let you know, and maybe we can find more people to join in. Thanks a lot. Have a good day. Have a good evening.
Yeah, thank you. Thanks for organizing this. Bye.
Thank you. Bye.
Bye.
Bueno.